Hello, my name is Amadea, and today we're going to be talking about transistors. We first have to ask ourselves, what is a transistor? A transistor is a semiconductor device that is used as an amplifier or switch to control electrical signal and flow. What are the different types? The different types of transistors include NPN and PNP. NPN, in an NPN transistor, the electricity flows from the collector to the base and then to the emitter. In a PNP transistor, the opposite happens. PNP transistors are less common and are practically only used for amplifiers. Transistors are super important in digital computers. When you put multiple transistors together, they create logic gates. Logic gates are how computers function. What is a logic gate? Logic gates are combinations of transistors in order to filter and order information to a desired outcome. A logic gate is a device that acts as a building block for digital circuits. They perform basic logical functions that are fundamental to digital circuits. Logic gates will make decisions based on a combination of digital signals coming from its inputs. Most logic gates have two inputs and one output. Logic gates use Boolean values, which mean false or true, 0 for false or off, 1 for true or on. I'll be going over 6 basic logic gates. There are others, but for this video, I'm going to go over these 6. The 6 include the AND gate, OR gate, XOR gate, Nand gate, NOR gate, and Xnor gate. Okay, let's now go over the logic gates. Before I go over the basic logic gates, I'll go over what I refer to as the simple logic gates, or the simple gates. The simple gates aren't actually logic gates. They don't have logic to them. There's 2 of them. It's the yes and not gate. The yes gate is if the input is 1, the output is 1. And if the input is 0, the output is 0. It's just a switch. The not gate, however, acts as an inverter. If the input is 0, the output is 1. If the input is 1, the output is 0. The AND gate. The AND gate only outputs 1 if both inputs are 1, hence the AND. If you look to the video, you can see me switch both switches to 1. This turns on the LED closest to the battery, which is 1. A real-life example of the AND gate can be signing in to an email. Both the email and the password have to be correct in order to log in. The NAND gate, it means not and. The not and gate is an inversion of the AND gate. So all outputs are reversed. All the outputs are 1 except for when both inputs are 1. If you look to the video, the LED closest to the battery is always on except when both switches are switched to 1. The NAND gate is one of the universal gates where it can be used for practically anything. A real-life example is making sure all 3 systems are working. For example, a tricycle. The systems are the wheels. A tricycle, if all 3 wheels are good, then the output is 0, or safe. But if one is bad, then the output is 1, or unsafe. In a real-life application, rather than a possible example, NAND logic gates are utilized in automatic temperature regulation circuits, and pretty much every security alarm, burglar alarm you've ever had in a house. The OR gate outputs 1 if either input is inputting a 1. So either or. If you looked at the video, when I have one switch on and not the other, it still outputs a 1 to the LED closest to the battery, or both at the same time. But if neither are on, then the LED closest to the battery isn't on. A real-life example of the OR gate can be used in a doorbell system with either the back or front door providing a signal to ring the doorbell. The NOR gate. The NOR gate, or the not OR gate, all the outputs are 0 except for when both inputs are 0. If we look to the video, the LED closest to the battery is always off, except when both switches are flipped to 0. Same as the Nand gate, the NOR gate can be used almost anywhere. The Apollo guidance system used roughly 5,600 of them. A simple example would be a washing machine, with the water level and the state of the lid being the inputs, and they determine whether to start the washing machine, the output. The XOR gate gives an output of 1 when either input is 1, but not both. If we look to the video, it's almost the same as the OR gate. However, when both switches are switched to 1, it isn't the LED closest to the battery doesn't turn on. A real life example of this is a game show buzzer, where either contestant buzzes the buzzer, but not both. The Xnor gate outputs 0 when either input differ from each other, or when both inputs are the same, then the output is a 1 or on. Essentially, if both inputs are 1, then the output is 1, or when both inputs are 0, the output is 1. If we look to the video, if the switches are the same, then the LED closest to the battery is on, or a 1. A real life example is a hallway light with 2 switches, but that's a little basic, so what they're really used for is kind of a boring answer. The Xnor logic gates are used in error detecting circuits, which are to detect odd parity or even parity bits in digital data transmission circuits. Basically, Xnor gates are mainly used in arithmetic and encryption circuits.